Welcome to Derivatives in Physics by Rashab, Sam, Salma, and Karina.
So we have this problem here with a particle moving on the x-axis with respect to time according to this equation. So t squared minus 3t plus 2, and it starts at time equals 0. And we're trying to find velocity and acceleration. So we can go ahead and graph x. So we know it starts at 2, 0. Cross the x-axis at 1 and 2. Go ahead and graph this. So we know that the particle starts at x equals 2, goes back, and then goes back forward again. So we have to find velocity. So what's the relationship between velocity and x? So x is measured in terms of meters. And we can just look at the units to figure this out. So velocity, or how fast something is going, is meters per second. Basically how x changes with respect to time, which is seconds. So what is that? That's just the rate of change, which in this case, since it's a curve, is just the derivative of this graph. So v of t, which is going to be velocity, is going to be the derivative of x of t with respect to time. So dx dt. And when you use Leibniz notation, it's x over t. It's very obvious. So the derivative is 2t minus 3. And you just do that using power rule. So we can go ahead and graph this. It has a y-intercept at -3, crosses the x-axis at 1.5, which is about here. Shouldn't be a line. So now we have our velocity. We can see over here where velocity is actually 0, that lines up where there's a horizontal tangent line in this x of t. Now that makes sense. Why does that make sense? That makes sense because at x of t, at this place, there is no movement. There is no change in x. That lines up with there being no velocity over here. So now we have to find acceleration. And it's the same exact relationship. If you look at the units, acceleration is meters per second squared. That's just how fast velocity changes. So acceleration is the derivative of velocity with respect to time. How fast velocity changes is your acceleration. So we can change colors over here. I like pink. A of t, which is your acceleration with respect to time, is going to be the derivative of velocity with respect to time. How velocity changes over time changing. It's the same relationship. So now we just take the derivative of 2t minus 3. Well, this is just easy. It's 2. So we know that the acceleration of this particle is going to be at a constant 2 meters per second squared. Done.
Don't forget to like and subscribe to the channel. If you have any requests or video ideas, feel free to comment down in the section below, or you can contact us via our email address provided by our YouTube channel.